Baker Hughes has secured an agreement to provide 77 kilometers of flexible pipe systems to Petrobras for Brazil's pre-salt fields in the Santos Basin. These systems are designed to handle hydrocarbons, associated gas, water injection, and deliveries are expected to commence by mid-2026, so next year. Manufacturing pipes that can withstand these high carbon dioxide concentrations and deep water pressures, I think that's the most important part, characteristic of pre-salt fields require advanced materials and engineering here. So they've got a lot going on.
Yeah, Brazil, I mean, they're on fire. I mean, it's a real kind of rocking place economically. They're really moving. But let's not forget, they are still an emerging economy. So for me, material innovation is really cool, but you've got to make sure it's cost efficient for them. I mean, that's a global issue. I mean, over here, over where Charlie is, I mean, we want to be efficient with our costs, but Brazil's got to be hyper focused on making sure it makes economic sense. So designing these pipes that can withstand high CO2, deep water pressure without actually blowing up your costs, it's really like trying to eat your steak, so to speak, on a ramen budget. So I mean, you want to make sure you've got that all figured out. Finding that sweet spot between cutting edge materials and cost control, it's going to be the real battle for them.
Yeah, whenever you're working with
What you got,
materials
Charlie?
like that. Yeah, well, look, this is my angle. As always, Andrew, I agree with what you're saying, always, right? But for me, what's really interesting,
Yeah, right.
this can relate to a client I was with last week where they work with a lot of new materials. The material science has been developed; it meets requirements, right?
Yeah.
But that's not designed for manufacture, and then they have to explore the feasibility of the manufacturing. So along with this, you think about where they're working with the compression it's got to be able to work with, what material choice they go with. I don't know, but I think, can they manufacture the chosen material to deliver the goods? And I see that as being not only a massive challenge, but the time that takes as well, and the cost it takes as well to explore that is incredible.
So what do you think the solution is to that specific point? And I'm going to jump off from there.
What is the solution? Well, again,
it's manufacturability.
Yeah, it's like we always say, you've got to be able to carry the requirements through all of that design and engineering knowledge through, right? You've got to be able to get to the point where, even for the exploratory side of the manufacturing process, that E-bomb to M-bomb process has got to be really good. So the guys have got a bit of a head start. So I would put quite a big focus on that area of the process.
So I think it's a people, process, technology thing as usual, but the people from manufacturing need to be involved right at the front end for manufacturability, design for manufacturing, those kind of principles. Then as you go forward from a digital critical thread perspective, I think you've got to have your simulation tools in place. That play will make sure it's got that manufacturability in it as well. So, your process twin, if we want to go there with twin, but a basic twin is, can I build this? Do I have the tooling? Do I have the fixtures? Do we understand what it takes? And then back to my point, making sure that it is cost efficient. You've got you're dealing with advanced material management in PLM. That's what we'd bring in. Use your PLM to manage your material specs, your cost breakdowns, and your compliance certifications. Manage that whole process. Hand it off to advanced simulation for early validation, modular validation as you go, so kind of modular simulation, and then make sure that your supply chain is also ready, so you got your supply chain integration as well. So a whole bunch of things.
It's a lot, and you're absolutely right. And again, I can pull on this example I had last week, but the other interesting thing was this company we spoke to, who work out how to manufacture these materials for said requirement. They also said the problem is, and might be the case of this, there's not an abundance of this material around, so you can't go breaking it too much because there's no more to do it with. So it really is a very interesting use case, and something I never really considered before. With these new materials, we don't have a lot of them, so that goes back a bit to what you're saying with the simulation, but also with the supply chain, right? Where's those materials coming from? How readily available are they? How much do you need? So,
you need a good supply chain integration solution, bolted in there as well. You got it.